Hi everyone, this is Taylor Saul with Applied CAX. Welcome to our MRL demonstration with Ryan Heron from Siemens. Several of our clients are using MRL and getting a lot out of the reuse functionality. The implementation is pretty light and there aren't a lot of licenses needed to get started. So if you're interested in learning more, please don't hesitate to reach out and contact me or Applied CAX. My email is tsaul@appliedcax.com. Thank you.
Great. So it's just a quick agenda, a few slides just to illustrate what we're going to talk about, and then I'll show you the interface and what it looks like from a user standpoint. Here, let me go ahead and advance the slide there. So just kind of overview what we're talking about, of what MRL really is and what it kind of means. And then we'll jump into NX and show what it looks like from a user standpoint. From a user, how not much is different from pulling tools. So it just has the ability to find a little bit more information out about the tooling since it's managed. And then we'll talk a little bit more about what it looks like from a tool admin standpoint. So you do need at least one tool admin that on a very surface level, so you can do it just literally just having managed tools with a revision, not much else to it. Or you can use the full capability of Teamcenter classification and the manufacturing process planner and other things as you grow into it more, if you want to utilize some of those tricks that are in there as well. So I'll just kind of gloss over those things, and it should be pretty straightforward and easy for you guys to understand. All right, so when we talk about Teamcenter for manufacturing and NX for manufacturing, from an end-to-end process, we kind of look at it like this. It's just a good illustration slide. Between all these different acts, I'll call them physical acts, or the parts of your process that happen in the real world and in the digital world, part preparation and then tooling and fixture design. There's the actual CAM programming, the CNC code. How does it get to the floor? How do you validate it on the floor? I don't know what type of standards you have for your setup guys, setup sheets, those kind of things. And then there's also, the planning for quality. There's the CMM programming, if you guys are CMMing your parts. There's the whole process plan, travelers, tool libraries, and the tool management obviously is what we're focusing on today. So we understand the holistic approach of everything that goes into making a part, from planning and production. So this is where the data and process management really kind of comes in. It's kind of where we hang out with this Teamcenter tool, working in the background for everything that you're going to do. So let's go ahead and take a look. I'm not going to waste any time jumping into, let's take a look at NX. There's a program we've already got going for us, and just show you what's different for the user. So just a standard aerospace type part here on a 5-axis machine, a standard program. And let's go ahead and look at the tooling here. We got a number of different pockets. So if I was to add in a new tool here, let's go ahead and insert in here. Same dialog you would normally get if you're familiar with the tooling dialog, and you can still use some of these NX templates if you want, or all of the NX templates rather, for the building up of a graphical tool. So this is what we call an NX parameterized tool. So you're using these NX parameters to build a tool. That's the same as before. You might have some extra options in here to export to library reference and stuff like that. Let's go back a second. Now, the big difference though is when you're looking into your tooling library. So when we say retrieve from tool library, still a standard list that you would get. This list of how you like to categorize things. If you categorize things by milling and turning or drilling, reaming, however you want to label your tooling, you can set up these classes to search into. And then from there, you can get more specific and dive into it. So if we look at end mills, let's go ahead and look at some face mills here, face mills, shoulder square mills, indexable. So let's go ahead and look in that category, or you can just look at all milling tools. But now you'll see we have a lot more options to search by, a lot more options to really sort through. You don't have to use them all. You can hide these options. I believe you can take them out of the dialog box here. But these options is what you're going to see again referenced here in a little bit inside the Teamcenter, and it gives you lots of options. One of the cool things that you can search by, I believe, is status. So now your tools all have a status, meaning they're in production or they're just a testing tool. Maybe it's something phased out. Maybe it's something that you guys didn't like how that cutter worked. It was a different coating or something like that that wasn't working well. You're getting a lot of galling on the tool, so you phase that out, and that's important because this status, if you come back to use that same program or that same tool, in following year, you can see that tooling assembly has been phased out, and it's something that you should look into and maybe reprogram with something else. So let's just leave it all blank and see what we get for our search criteria. This is the same process you would use before, and like I said, from a user standpoint inside of NX, they're not seeing anything different other than some extra options. So now we have what's called a library reference. So this is kind of how it's stored in NX. These are like item numbers. What's more important is the tool description. You can have this field here filled out if you really have multiple facilities and things like that. Where it's located, so what group or what plants. Maybe you can even categorize different work cells as a plant facility if you want, and have a designation there. And just some different things, depth of cuts, what type of machine adapters on it. These are all HSK, very popular in a lot of German machines. Cutting diameter, there's some critical ones that these need to be filled out. Cutting diameter obviously is going to be one of them. Interesting. So all kinds of different fields there. And I actually think I have this one open in the background that I made before. Let's go ahead and take a look at that one separately. But let's go select this here. I think that's going to go into pocket 80 there, or pocket 08, and take a look at it. Now I should mention why this is thinking here. I am running a virtual machine, so half of my laptop right now is being used to run a Teamcenter server. That wouldn't be standard. You would typically use a separate server in-house. So for my computer going a little bit slow right now since it's bogged down by two different things, and on top of that presenting through GoToMeeting. So sometimes things might take an extra half a second that would not normally take that slow. But as you can see here, here's a whole shoulder mill built up, complete with the inserts. It's a complete assembly, and that's the tool. So we're using a solid assembly of the tool, as your cutter. It's got it's NX parameters in here as well. It's different tool number registrations, all that stuff if you want to use for different cutter comps. However your company defines it, you have all those numbers stored from Teamcenter as well. So pretty simple. Nothing much different for the user. Now that they know, these tools are managed, they're going to get more accurate, tooling right out the gate, especially using the solid tooling. You don't have to use the solid tooling. It can also be parameterized. I'll show that in a little bit. But let's take a look at this program. This one's already made. I just want to verify it real quick. So here we are. We have two things here. We have the actual solid assembly of the tool. In NX, what it uses for the tool path creation, and this is standard with or without MRL. If you use a solid cutter that you imported from solid, NX always uses a parameterized tool to create the tool path because the math is easier. It understands the very specific diameters and things like that from the parameterized tool. And we can see that, go around from the parameterized tool. But, just like you would unmanaged or managed, doesn't matter. You can also look at the full assembly. And let's go ahead and slow this way down. You can actually see it rotating around. So the simulation is pretty good. Now what happens is this is just verification. So this is again for the toolpath creation. But when we get to the actual simulation of the machine, so reading back we can read back the G code if we'd like. Show that here. So here's the posted G code for that. I'm not going to do that because it's going to run through the whole machine. Let's just skip to this particular program, and we could actually look at very specifically this operation and the entire. Let me back up so you can see everything move. So there's the whole setup moving around, and that is off of the 3D model. right? So simulation is always using the 3D model of the tool. So how did we get there? How does this become, you know, part of your library, and how does NX interpret that? Well, let's take a look at this tool here. Actually, let's back up. I made this one a little bit ago. I didn't finish it, but it'll show the necessary parts. So similar to the current process you would use if you wanted to use a solid tool or some sort of form tool, NX recognizes it as cut and no cut, and then there's two key I'll say coordinate systems you need to use. First off, I just created a cylinder body. You can see here my model history. I just created a cylinder, simple, plain. I mean, you can make this really complicated if you want to make really complicated form tools. I just put a chamfer in the front. Actually, it doesn't quite come to a full tip. That doesn't matter because it uses a tracking point. And then I split the body in two. So the key thing is you need two different split bodies. And from there, you want to put what's called your CIP coordinate system. So that's the tip. You know, that's going to be your tool tip, your tracking point, and then an MCS. And the MCS is going to be used as your mounting point towards the machine. So you have your CIP coordinate system going towards the cutter tip, and then your MCS going towards the machine. And once you have those two set up and you have two different bodies, you can categorize them by color. So you can categorize the cutting edge with this specific color. I can't remember what the number is, but that's irrelevant right now. And then the non-cutting with a different type of cutter or color. Or you can use what's called groups. And you can create a group called group cut or group no cut. And then you just put those solid bodies, you select those to go in these groups, right? So very basic NX modeling skills, and you're just labeling it cut and no cut. And then you label your two most important MCSs as CIP and MCS. And you can actually have some more in here as well for inserts, and I'll show you that in a little bit. But that's really all there is to it, to creating this. And then in a managed environment, what you're going to do when you save it, it's going to save it as an item number with a revision, and then you're going to send it to what's called a classification. So to set that up is fairly easy. Let's take a look at a little bit more complicated example, and this is a full assembly. So right, this one here is just a component. That's important to note. Now this is going to be a tool assembly. So this is after we've built it up in the resource library. And what between MRL and NX, what it does automatically for you is it brings us into Machine Tool Builder, and it's defined as what's cutting. So you has your cutting geometry, and again, this would be like I said, in a tool group or a color. And then your non-cutting, so all your geometry that you don't want to cut anything, right? That's the non-cutting geometry. And it's automatically going to create what's called the spun outline. Same thing that you would see in turning. So this is your cutting spun. To the user standpoint, they're not getting, you know, they don't have to learn much different to the user. You're still using tools the same way you would use them in NX CAM. They're just coming from a managed environment. And there's some other, you know, little bells and whistles there too. So, you know, that's what's used in simulation. And let's go ahead and move on from there, I guess. Kind of recap there. So again, the NX CAM users quickly pull these tools out of the library. You can use full managed MRL or MRL Connect. Everything I just shown you is the same process. You can send those finished CAM packages to the shop floor with Teamcenter, shop floor Connect if you guys are interested in any DNC products. But ultimately, this just makes the programmers more efficient, more quick. Getting tools that are made correctly. You're more confident in your simulations since you're able to use the 3D tooling data, and you'll be more productive when you can get the up-to-date revisions that are revision controlled to the floor. And there's no question, especially if you run a job or that you haven't ran in a while, there's no question of what type of tooling you programmed it for before. Okay, so let's take a look at what it looks like inside of Teamcenter. How do you get things out of vendor catalogs, other places you can find tooling, and accurately managing all this. So this is going to be the nuts and bolts to getting everything working. What a Teamcenter admin would see, or what your tooling admin would see. Let's go ahead and take a look back at this part. Should be the same tool I was just showing you before. Hold on here as the graphics update. There we go. So this is the Teamcenter interface. You know, it's a little bit more complicated as far as just different windows. It's not nearly as sexy as NX is, but it's very, very useful, and it's pretty straightforward. So on your left here, this is just a kind of like a search bar type area. It gives you your quick links or your history, some open items, some different tools. You don't need to have this up all the time, but you know, so this is just kind of a navigation area. Same thing you would see on a lot of websites of sorts. And you have two main windows here between these two. Here's one for a graphics window. You can see the JT files. You can see all the properties that are included in the part. You can automatically create drawings and set up drawings. So here's a reference of what these drawing details are going to look like up here in the corner. I can make that bigger if I move these boxes open. Again, here's a drawing that's automatically created from it. Get this go-to out of the way. Here's a smaller example for JT. So you have different visualization things and different ways of just kind of looking at everything from within these windows. The important thing is these drawings that are automatically created, referenceable for the tool presetter guy or whoever it is. There's a better PDF view that you can see. BOM views, all kinds of different things for setting up these assemblies. All right, so that's just kind of a quick overview of what we're looking at here. So what happens when these tools are brought into NX? They're categorized in what we call classifications. And these classifications are fairly straightforward to follow. Let me collapse these to show you. So here's everything that we could possibly use within manufacturing. We have vendor catalogs. So this is stuff that we don't own. We don't have these in-house yet. They're just, they're out there ready to buy. Here's our tools that we do have in-house. So this is our tool library. We also have libraries set up for machines and devices. So all your machines and all your devices can be managed. So, your fixtures, your types of devices that can be in here as well. Factory resources. So this could be robots or different conveyors, something like that, if you want to go that far to manage all that equipment as well. And including your machining data libraries. If you want to manage your machining data libraries with how they, how your feeds and speeds and all that works in here as well, and your templates. So within the tools, let's look at what, how it's broken down as tools that we own. You have two major categories. You have components, and then you have assemblies. So as most tool cribs are, you'll have many different tools, whether they're in drawers or if they're in little candy machines that a programmer has to go check out, so it keeps track of them. And those components are categorized as you'd expect: turning, milling, drilling, all the way down to solid drill, twist drill, let's say fluted drill, something like that, right? So all the way, and again, this is very expected of how the categories should be built out, but you can customize them for your company's libraries as you see fit. And basically, what you do is you select a component and you say, well, I want to use, let's look at one of these fluted drills, and I want to, this might be a drill I need. Let's say a 20 millimeter drill. Take a peek at it. Here's some information around it so I can see kind of what it looks like, from within my tool crib. You say, okay, yeah, this is the tool I'm going to use, and I'm going to build it up to an assembly. So let's go ahead and send this to what we call the resource manager. So this is where we can, look to see what type of holders are available and really put it all together in an assembly. In this view, we can see here's some critical information that we need for NX. There's a lot of information here. So there's all kinds of things you can put in these fields, connection types to certain machines, if it's a cutter that has multiple tracking points, all kinds of things in here. But what we do is we filter it down to, let's see just what we need for the NX interface, right? So some of these should be filled out. These would help with the parameterizing of the tool, point length type of thing. So we might not have all the categories filled out right away until you build it up, because you don't know how far of a stick out you want type of thing. And then the next step would be to build this into an assembly. So what we can do from here is we create an assembly into our assembly categories. So let's go ahead and take a second back and look at that. So in our assemblies, let's go into that same category. This tool assemblies breakdown is the actual reference library that you're seeing inside of NX. So if I go to a milling tool and find that same face mill that I was playing with before, let's go ahead, that was a shoulder mill, I believe. Search for it here, yep, that's the same one. Let's go ahead and take a peek at that in Resource Manager as well. Just going a little bit slow to update the graphics. And here we go. Yep. So this is that same tool that we were playing with before, and now it's built up in an assembly. And what it does inside of Resource Manager is you have these different plugs, we'll call them. I think they're technically called, yeah, the GCS connections. But these plugs are the different coordinate systems for how the part goes together. So if we take a look at just the tool itself, that one has an MCS for the machine side. So what does it connect to for a holder? And then it's got, you know, it looks like seven different inserts that it takes. And each one of these plugs, then you can do what's called a guided component search and search for all the inserts that would fit in it. So let's go ahead and say, oh, well, let me edit the tool. And a guiding component search, and this is the real powerful part of MRL, is going to show me automatically what inserts I have available in my library to use inside of this tool. So what inserts fit, and that's because those different, yep, so it only comes up with one. I only have, oh, I'm sorry, I clicked on the machine side, so it's only giving me one option for a holder. If we can take a peek at this in the viewer. So I did a guided component search on the holder. So it's a standard HSK arbor holder. And just from this interface, I could click OK, and it inserts it into the holder here. And the same thing for the inserts. So by using this guided component search, you only really have to start with what you're looking for. So if you're looking for a 20mm drill, you start with that 20mm drill, and then you search for the holder. In this case, I would have started with the, you know, I think this is a 80mm face mill. So I would have started with the face mill and then search for a holder and search for an insert. And this is where I say that NX and Teamcenter cleverly will put it all together for you and build that 3D model, build that spun outline, and do that from there. So you put it together. It's quite simple here. It just shows you the different MTSs. You don't really have to have all these expanded. It's just a bomb view to show it all if you want to kind of see what's in here. And then what you would do is you would use this little icon. I'm going to save it. So there's an icon up here. It's already made for me, so it's not showing it, but it says Create Update NX Tool Assembly. And that's all you have to do, and it creates this assembly for us. It goes in, does the spun outline. Here we go. It's highlighted up for me. Should give me a dialog box of what it's asking me to do. Now here we go. So when you do this, you can say identify cutting and non-cutting geometry, generate spinning geometry, set tool junctions, write NX part attributes. You can create setup sheets automatically, extract holder data. So this is where I say it's quick and simple from the admin standpoint. Once you put this together, you know, I want to use this holder with this insert and this connection. It just creates it automatically. It's quite nifty, and that's how you end up with you know, the setup sheets and all that, as we've referenced before. Everything's stored in what's called Resource Manager, and then that information, the NX tooling library that it's looking for, is looking into Resource Manager. And these are what we consider resources. Yeah, let's go ahead. Let me show you the process real quickly. Let me back out a couple of these. So I don't need these all open. And I'll just kind of start over from what it would look like. So let's say we're going to create a new tool, and I'll just use something simple. So it's going to give us automatically assign some numbers, or you can put in your item types however you want it. This is your company's tooling numbering strategy. It doesn't matter what it is. So we'll just call it test. I do tests all the time, and we'll do test drill. The important thing is it's going to be a tool, right? So this is how the item type is structured. You can do, like I said, all kinds of different things. It might not be a tool, it might be a fixture or something like that. But in this case, it's a tool. So we're creating a new resource. And in this resource, we're going to start with the drill, because I know I might need a, let's say an 8mm drill if I have one. So the first thing is I want to tell it what category we're putting it in. So this is a new resource. We're going to put this in tool assemblies. Let's say it's a drill, not a spot drill. Let's just do a normal drill, normal twist drill. Right, so that's what it's going to be. And this is where it kind of takes a second. So I apologize about my computer running a little slow. You might need to give it a description, some comments, some different things. We don't need to fill out too much just yet, because a lot of that information is going to populate automatically when we actually select the drill. Let's go ahead and save it. All right, ready to go. The first thing we're going to do is add a classified component. So the components, like I said before, are in our resource library here. Here's our components. This is everything we own. We don't want to go get things out of the catalog just yet. There is a process for looking at things in the catalogs, and I'll show that in a second. But let's go ahead and find a drill. And actually, now's a really good time. I can show you what happens if you don't find the drill you want, or the options we have to do things live for searching. So here's all the fluted drills that we have, and I'm going to select one. I think, what did I say? I was looking for an 8mm one, or here's 8 and 5. I don't see an 8mm drill. So if I don't see an 8mm drill, I can do what's called a live Tools United search. And let me see if my login works. Tools United is on the internet. It's a small, I think I would consider a small, inexpensive fee to pay yearly, I believe they charge. And it's a database of all the different tooling vendors. So I should have gone back and done a different search. Let's say I want, what did I say, 8mm? I want to show you how that works. Let's do cutting diameter. That's what I was looking for. 8mm search. And if I do a Tools United search now, if I didn't find what I wanted, it's automatically going to search the 8mm I was looking for. So here it's giving me different options: stub drills, jobber drills, whatever I'm looking for, different manufacturers, bearding, Kennametal. Every manufacturer is on here. I could filter out some more too. So if I wanted to filter by manufacturer, let's say I just want Kennametal. And right from here, I can find the data that I would need from Kennametal or Sandvik or something like that, and bring that into the library. So I don't have to go input all that stuff on my own. I can find it on the fly through this Tools United search. And like I said, it's relatively inexpensive. I think it's, I don't know, like $50 a year or something, but don't quote me on that. You'll have to look into it. So we've partnered with them to provide all this data online in what we consider, what's called the GTC, or Generic Tool Catalog format, which is actually an ISO standard. So let's go ahead and use, here's that one I found. Yep. All right, so now that's in there as our resource. It doesn't have any inserts or anything in it. It only has a blue puzzle piece to it. So this says, you know, it only needs a holder. So then we can do a guided component search and find a holder for it. That's working on it, looking into our library, finding what type of holders would fit this particular drill. So it's found a single side lock weld on arbor. Actually, it's found a bunch of them. So we have a bunch of different options of components that we could put in this to hold this. Different 8mm ones here. There is certain ranges, and there's actually a couple different places for ranges. So there's ranges for length as well as diameters. So you can actually give your tooling presetter guy a range that says, hey, this tool, you know, because what you program it to is never the exact specific length. So you can give your programmer or your presetter guy a range that the tool has to fit within. And same thing for searching for holders of that sort. But let's go back to look at some of these holders. Let me quickly find one here that I'm going to use. Let's just grab this one. Yeah, here's one I was trying to pull up. So there is some options in here to modify things fairly quickly. So once you put the tools together, right? And so we have an NX assembly here. This is the NX assembly that came out of us putting it together. But what if you wanted a different stick out length or something like that? It's actually quite simple to do that. You would just go into the part file, because all of this has a part file that's referenced. So here's the part file, and you would physically just move the tool one way or the other in the coordinate systems as well. And if you needed to modify some reduced shank area, something like that, all that can be done in the 3D model. And what you would do is, and I know you're concerned about deleting and redoing the cut geometry, but you would go in and you would delete this cutting spun and non-cutting spun after you made any changes, and then you just save it back in. And once you're back in the Teamcenter, you would go to that item and go back to that icon I showed you right here, which is create update NX tool assembly. So once you've modified the actual NX assembly and whatever that cutting spun and non-spun is, you would just regenerate it from this standpoint. So there is some tools that would kind of help with that, and especially how you mentioned a lot of the reduced shank area and stuff like that. There's a lot of properties in there to find that, and it may not be specific, like you said. You might have a mile clearance on what looks like on the parameterized tool, but that's the power of having everything as built as a solid tool as well. So there's a couple more things I need that's really important. I want to finish up and show you. So here's how the vendor tool catalogs are. And the reason at the beginning I kind of stressed how we set up components, and then we set up assemblies, and then this assemblies structure here is the same as your library structure that you're referencing in NX. That's because the different tool vendors, they don't categorize everything the same. Here's one from ISCAR. They just start with tool item and then inserts and adapter items. And then you go in there and you go from that. So Sandvik does it, might be completely different. They have things labeled different. Here's multi-tools, milling cutters. By the way, we did add multi-tool support. So if you have tools that have multiple cutting edges and multiple tracking points, very popular in turning nowadays to save space on the turret, we support that as well. Let's see, Kennametal has different tool items here. So how do we get these into NX? You can do the online version that I showed you before with Tools United. That's something we have specifically set up with them. It's embedded into our interface that we can search by. But if you want tools specifically from these vendors, and this is something you probably do only once a year, when Sandvik comes out or ISCAR comes out with their new catalog for the year, you could request it specifically from them. They do have a download site online, but most of the free download stuff online is in metric. So you would just email your tooling guy, whoever you buy your tools from, say, hey, I need a GTC catalog for Siemens in inches or millimeters, whatever you guys use, and then you get a big file, and that big file has all the parameters to build these tools. And a lot of them have coordinating step files that go along with them. Obviously, you would need it for the milling and stuff, the insert style cutters. And it's quite a simple process. So then what you would do to bring in those resources, find one here. I don't know, I got to be in Resource Manager to do it, but here we have what's called Import GTC Package and Map Catalog. So you would find this catalog. You can import the 3D models, map those products to your MRL classes, right? So I mentioned they have different naming structures for their catalog versus what we have in NX. So you want to map them accurately. So the drills go into drills and mills go into mills. And you can also delete that because the package can be kind of big. It does take a while if you do the entire catalog. You can imagine they probably have some on the order of 10,000 parts. But here's what you would do. You would see whatever in this file folder on your local computer. So I'll show you where it's at on my local computer. Real simple. It's just a GTC package downloads. And here you have the step file, log file, and a detail file. Here's the one for Kennametal as well. And what Teamcenter does is it just looks right into this big zip file, and then that's going to import all the products, and it's going to go through and do it one by one. It can take, on a server, probably 24 hours to do for an entire catalog because it's going through and it's building all the step models and all that stuff. But then you have that at your fingertips in this classification thing right here. You can go right into these vendor catalogs and look and see what you're looking for. So if I'm looking for, I don't have the full ISCAR catalog, but let's say I'm looking into ISCAR and I need to see what milling cutters they got available. I can search for specific sizes, blah, blah, blah. Let's just look at all of them. And then I can see right specifically what ISCAR has. And once I determine, okay, this is what ISCAR has, it's something that I'm looking for, I can then, so this might be as a chamfer mill, big ugly thing. If it's something that I want to use, then I would then move that from the vendor catalog. I would create a resource in my category of tooling, And when you do that, all this data information gets mapped over. So that's all in there. You might have to put some extra stuff in there, however you want to label it. And then that becomes something that's available to you in your components. And then that's the resource. So that's kind of the quickness of it. You can imagine, trying to get all the step files and all that stuff one by one every time you buy a new tool can sometimes be a little bit cumbersome. So to do it all at once, to have it at your fingertips is really powerful.
Yeah.
Okay. So again, we talked about it from the standpoint, you start with your vendor catalogs, you're looking at the tooling, you're searching, you then bring them into your components. So everything that you buy, you then label as one of your components. When you're creating different programs and you need different types of tooling and you're going to build it up, so you create an assembly, and this is where everything has a revision to it. Showed you kind of all the bells and whistles go with that. And then the CAM system, you're just programming it with normal as you would do before. There's also the step of getting it out to production. We actually interface with Zoller presetters pretty well. And again, if you want to use Shop Floor Connect for sending DNC programs and the tooling setups, all that can go out to the shop floor right to the machine. So this is kind of the whole manufacturing resource management structure. Again, you can do this with the same thing with your fixtures. You can do the same thing with your entire machine tools if you want to have templates set up with your machine tools at certain revision levels type of things if you want to really lock down your processes. So that's pretty much it. Actually, this slide, I foolishly moved it to the bottom. This was supposed to be at the beginning. This is where I was talking about the different categories of the interface and what you're really looking at. And then again, the automatic placement of these inserts and the different different stick out lengths, all that is available through the interface there. Automated drawing creation is also really big. People spend a lot of time creating setup sheets. So tooling admins can do all this stuff, again, be more efficient, more confident, more productive. That's kind of the point of it. And I don't want to go out, I don't want to sell you on the fact that it's going to solve, it's just going to plug and play. You do need to set up your tooling libraries. Any good shop spends time managing their tooling libraries. So you do need to set it up at least the first time to get going, to have that built up. So I highly suggest, spend some time, make sure you get your accurate tooling libraries set up as you'd like to use them.